Today's lesson is all about the sign test, when to use it, how to do it, and how to report the results. Hopefully, this table looks all too familiar from the previous lesson, and hopefully you remember that the sign test is used when a study looks for a difference, has a related design, and uses nominal data. Think of it as being used for simpler yes-no, increase-decrease kind of comparisons, great for smaller or simpler experiments. Let's look at an example. A psychologist wanted to investigate whether people feel more focused when studying with instrumental background music or when studying in silence. Each participant carried out both conditions. This is looking for a difference, not a relationship. The study compares focus in two conditions. The same participants took part in both conditions, so it's a related design, repeated measures. And the data is nominal because each person either felt more focused in the instrumental background condition or the silent condition. So for this, we would use the sign test. The alternative hypothesis in this study was that students rate their focus as significantly higher when studying with instrumental background music than when studying in silence. So previous research would have indicated that instrumental music can improve concentration. If there had been no such previous research indicating anything, then a non-directional hypothesis would have to be used. But in this case, it is a directional hypothesis, which translates to a one-tailed test when looking at the critical values table. Each person rated how focused they felt on a scale from 1 to 10, once while studying with instrumental music and once in silence. You can see their individual scores in this table. You might now wonder, hold on, this is a subjective scale, so it's ordinal data. Really, we should be using the Wilcoxon test. Here's the key idea. When we do the sign test, we're not analyzing those numbers directly. We just use them to work out the direction of change, whether each person's score went up or down or stayed the same between conditions. Once we've done that, we throw away the actual numbers. We basically reduce our data to nominal categories, increase, decrease, or same. Now we use these two sets of scores to calculate the difference between the conditions. So step 1 is to find the differences between the two scores for each participant. It doesn't matter which way around you subtract, just stay consistent. So 3 minus 8 equals minus 5, or the other way around. 8 minus 3 is plus 5. But again, whichever way around you do it the same way around for each one. Make sure you write the sign plus or minus in front of each number. This saves you the next step. If there's no difference, just write 0. Because we already wrote the signs in front of the difference, we don't have to write them out again. I just have it here for clarity. Now we need to add up the number of minuses and the number of pluses, just ignoring the number itself, and also ignoring the zeros. The calculated value of the sign test, S, is the smaller of the two totals. In this example, we have 3 pluses and 12 minuses. So our calculated value of S is 3. This number represents how small the minority pattern is, how few people showed the less common outcome. Now we need to find the number N, which is the number of participants included in the analysis, but we ignore any zeros. So although we had 16 participants, one of them showed no difference. So this leaves our N to be 15. That's the number we'll use when we look up our critical value in the next step. Next, we find the critical value for our test. We need 3 bits of information to do this. Is the test one- or two-tailed? In our case, it's one-tailed because the hypothesis predicts a direction. The significance level is assumed to be 5% unless stated otherwise. So P equals smaller than or equals to 0.05. And our number is 15, as we just figured out. From the critical values table for the sign test, we now find the corresponding critical value based on these pieces of information. So it turns out that our critical value is 3. Now that we know our calculated and our critical value, we can interpret the result. The rule for significance for the sign test states that the calculated value has to be equal to or less than the critical value for the result to be significant. This is indeed the case for us. Both our calculated value and our critical value are the same, 3. This means we can reject the null hypothesis and accept the alternative hypothesis and conclude that there is a significant difference between our conditions. Our results are unlikely due to chance. When you report your findings, use the same structure we practiced in the last lesson. You can pause here to give it a go. Ideally, you wrote something along these lines. For a one-tail test, where p equals 2 or smaller than 0.05 and n equals 15, the calculated value 3 is equal to the critical value 3, so the result is significant. The alternative hypothesis is accepted. Students rate their focus as significantly higher when studying with instrumental music than when studying in silence. Now have a go at this example exam question. Pause here to work it out before I show you the mark scheme. Here are the workings for the first couple of steps to calculate the calculated value, which is 2, and the number, which is 10, due to disregarding the participants where no difference was found. Looking at the critical values table now, we can see that the critical value is 1 based on the number we just calculated, and knowing that we have a one-tail test and a 5% probability level. Our calculated value of 2 is greater than the critical value of 1. Taking the rule again that's written underneath the table, because significance is only achieved when the calculated value is less than or equal to the critical value. The result here is therefore not significant. That means we accept the null hypothesis. Participants did not rate inferential statistics significantly more positively after completing the course. You can pause here and write up your results using that formula we've gone through before. It's good practice to get into the habit of doing that. I suggest using it because it ensures that you include all relevant details, even if it may seem like a bit more information than may be required to get full marks for a simple question like this one. So this is how the results could be reported fully. For a one-tail test, where p equals smaller than or equals to 0.05 and n equals 10, the calculated value, 2, is greater than the critical value, 1, so the result is not significant. The null hypothesis is therefore accepted. Participants did not rate inferential statistics significantly more positively after completing the course. You made it to the end of the lesson, and hopefully you are now able to determine when to choose a sign test, how to do the sign test, how to determine significance, and how to report your findings. I will leave you with a practical do-this-at-home version for carrying out an experiment and then performing the sign test. Check whether your reaction time is faster with your dominant or non-dominant hand, and use the sign test to analyze your data and see if the difference is significant. It's fun, quick, and a great way to practice your ability to calculate the sign test and report the results. Have fun!